A new Earth? The discovery of Trappist-1e. Our universe is vast. It's teeming with billions upon billions of stars. And well, around many of these stars, we're finding planets. These planets, outside our solar system, are called exoplanets. In 2017, astronomers made an incredible discovery. They found a planet called Trappist-1e. This exoplanet orbits a star named Trappist-1. This star is much smaller and cooler than our own sun. It's what we call a red dwarf star. Trappist-1e is special. It's one of 7 planets in the Trappist-1 system, and it sits in the star's habitable zone. The discovery of Trappist-1e sent ripples of excitement through the scientific community. It was a major step forward in our search for life beyond Earth. Here was a planet, similar in size to Earth, orbiting a star at a distance that could potentially allow for liquid water. Could this be a second Earth? The discovery of Trappist-1e was a testament to the power of modern astronomy. It hinted at the possibility that we might not be alone in the universe, and it fueled our desire to learn more about the worlds that exist beyond our own. The Trappist-1 system is quite different from our own solar system. This system is located about 40 light-years away from Earth in the constellation Aquarius. At its heart lies the red dwarf star, Trappist-1. This star is much smaller and cooler than our sun, and it emits a faint reddish light. Orbiting Trappist-1 are 7 Earth-sized planets. That's right, 7! These planets are packed tightly around their star, much closer than the planets in our solar system orbit the sun. If you could stand on the surface of Trappist-1e, you would see the other planets in the sky. They would appear much larger than the Moon does from Earth. Imagine that. The close proximity of these planets to their star has some interesting effects. For example, it's likely that the planets are tidally locked. This means that one side of each planet always faces the star, while the other side is always facing away. Let's zoom in on Trappist-1e. This planet is slightly smaller than Earth and is estimated to be about 0.9 times the mass of our planet. It orbits Trappist-1 at a distance of about 0.028 AU, completing one orbit in just 6.1 Earth days. That means a year on Trappist-1e is only 6 days long. Since Trappist-1e is tidally locked, one side of the planet experiences perpetual daylight, while the other side is shrouded in eternal darkness. This creates extreme temperature differences between the two hemispheres. However, there might be a region on Trappist-1e where temperatures are just right for liquid water to exist, a key ingredient for life as we know it. Scientists believe that Trappist-1e could have a rocky surface, possibly with volcanoes and a thin atmosphere. But we need more observations to confirm these theories. The habitable zone. Could Trappist-1e support life? Not too hot, not too cold. The habitable zone is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. And Trappist-1e sits comfortably within this sweet spot in its star system. Now, being in the habitable zone doesn't guarantee a planet can support life. Venus, for example, is technically in our sun's habitable zone, but its thick atmosphere traps heat, making it the hottest planet in our solar system. Trappist-1e's potential for habitability depends on various factors, including the presence and composition of its atmosphere. If it has a suitable atmosphere, it could trap enough heat to maintain liquid water on its surface. The search for life beyond Earth. Why Trappist-1e matters. The discovery of Trappist-1e has intensified our fascination with finding life beyond Earth. Here's a planet, relatively close to us, that might just have the right conditions for life to exist. Now, we're not talking little green men here. We're talking about the possibility of microbial life, similar to the earliest forms of life on Earth. Even finding evidence of tiny organisms on Trappist-1e would be a monumental discovery, fundamentally changing our understanding of our place in the universe. Trappist-1e presents us with a unique opportunity to study a potentially habitable world. By analyzing its atmosphere, we can learn more about its composition and possibly detect signs of biological activity. Unveiling the secrets of Trappist-1e, ongoing research and the future. Scientists are eager to unravel the mysteries of Trappist-1e. Powerful telescopes like the James Webb Space Telescope are being used to observe this distant world. The JWST, with its advanced instruments, can analyze the light passing through Trappist-1e's atmosphere. This analysis can reveal the presence of certain molecules, such as water vapor, methane, and oxygen. Finding these biosignatures would be a strong indication that life might exist on the planet. Studying Trappist-1e, is not just about finding life elsewhere. It's about understanding the conditions that give rise to life and the incredible diversity of planets that exist in our universe. The journey to understand Trappist-1e is just beginning, and the discoveries we make along the way are sure to be astounding.